Okay, problem number 1. Say that a radioactive sample contains 2 grams of nobelium. If you know that the half-life of nobelium is 25 seconds, how much will remain after 3 minutes? Before we proceed, let's review first what is a half-life. A half-life is simply the amount of the substance present. At the half-life is simply the time wherein the amount of substance is reduced to one half. So let's say to begin with, the amount of nobelium present is 2 grams. So if its half-life is 25 seconds, it means that after 25 seconds, the quantity of nobelium present is only 1 gram. So half-life is simply the amount of time where the amount of the substance is reduced to one half. So that is called the half-life. Okay. Having that said, let's now solve the problem. Say that a radioactive sample contains 2 grams of nobelium. So that is A, or simply AO, is equal to 25 grams. 25 grams. Okay. If you know that the half-life of nobelium is 25 seconds, how much will remain after 3 minutes? In order for us to be consistent with our units, we'll just use time in terms of seconds. So let's convert minutes, 3 minutes to seconds, which is 3 times 60, that is 180 seconds. 3 minutes is 180 seconds. Okay, say that a radioactive subsample contains 2 grams of nobelium. That means at t equals 0, we have A, which is equal to A sub O, because that is the amount of substance when t equals 0, or that is simply equal to 25 grams. Then the equation is A equals C e to the kt. We have derived this in our previous video, right? A is equal to C e to the kt. So it is an exponential growth or decay. In this problem, we know it's a decay. So we can either write negative in k, or let's just simply use positive k anyway. As I will show you later on, it will become negative because of the given. So the equation itself will recognize that it will be a decay problem because of the given the given quantities. Okay, so at time equals 0, A is equal to 25 grams. So that is, we write here 25 grams, C e to the power of k, that is at time equals 0. So k times 0 is 0, and e raised to 0 is 1, because any number raised to 0 becomes 1. So we have here 25 equals, 2. 25 is the time of 25 is the half-life, but the amount of radioactive substance present is 2 grams. So 2 at time equals 0, the amount of radioactive substance present is 2 grams. Okay, so that is 2 grams. Okay, so 2 equals C. So C now is equal to 2. Okay, so then we substitute for the equation. A equals, instead of writing C, 2 e to the power of k times t. Now at t equals, the problem says, if you know that the half-life of nobelium is 25 seconds, so at t equals 25, since it is the half-life, then A becomes 1/2 of AO, or the amount of substance initially present, which means it becomes 1 gram. 1 gram, alright? So we substitute that in our equation, this equation. Okay. So 1 gram, A is equal to 1 gram, C is equal to 2, e to the power of k. That is when time is equal to 25 seconds. Okay, so 1 equals to e k times 25. Okay. What we will do is we divide 1 with 2, we transpose 2, so we have here e to the 25k, right? 25k. And then we take the natural logarithm of both sides in order to extract k. So this is ln of e to the 25k. So what we will have is ln of 1 half ln of 1 half equals 25k, right? So k now is equal to ln of 1 half divided by 25, which is negative 0.027 or 27 something, which can be rounded off to negative point 0.028. Then now we are ready to solve our what is the last unknown. How much will remain after 3 minutes? Okay, so now we can so that is at t equals to 3, which is 180 seconds. Okay, 180 seconds. The question is, how much of the substance will be present during that time? So we can replace the equation now. We have A equals, C is 2, right? So e to the power of, but k is negative 0.028, then t. Okay, so we can replace now the t with 180. So we have A is equal to 2 e to the negative 0.028 times t, which is 180 seconds. And solving for A using your calculators, we obtain a value of 0.013 grams. Okay, so from 2 grams after 25 seconds, it becomes 1 gram. After 3 minutes, it becomes 0.013 grams. By the way, K is the proportionality constant, the decay constant of decay of a radioactive substance. So it will be negative 0.028, which is the unit in nuclear physics is berkelium. So negative 0.028, that is negative 0.028 substance per second, which is what we call berkelium. The unit is berkelium. Okay, so that is the answer. The radioactive substance nobelium decays. To start with, it has 2 grams, and then after 25 seconds it becomes 1 gram, because 25 seconds is the half-life. After 3 minutes or 180 seconds, the amount of the substance is already very small, which is 0.013 grams. Okay, thank you very much, and see you in our next video for another example. God bless, guys.